Hello, Mrs. V here, and I'm going to give a quick lecture on molarity. Okay? All right, so let's get started. So if you guys are a little bit still confused after this lecture, you can go look in your chemistry book, pages 480 to 482. It talks about molarity. A couple definitions before we get started. Molarity. Molarity is the number of moles. You guys have all learned about moles and how to go from grams to moles, moles to grams. Of solute. Remember our solute, as we talked about, is the thing that is dissolved. So it's like salt in salt water. Okay? Dissolved in 1 liter of solution. It tells us the concentration of the solution. So it tells us how much of the solute is in there. Remember when we talked about solutions and we talked about saturated and unsaturated? Well, we can have what we call a molarity, which can kind of give us an idea if it's saturated or unsaturated. It's a way of calculating it. So it's how much of the solute, or if you think about salt water, how much salt is in the water. Okay? The equation for molarity is, it's a big M. Remember, moles is little m-o-l. And so big M equals moles of solute over the liters of solution. Now this is a big thing to remember, liters. Remember, it's liters, not milliliters, but liters. So our first example here is you would be told there's 2 moles of sodium chloride salt in 1 liter of water. Well, you take the 2 moles sodium chloride, divide by 1 liter, and you get a 2 molar or 2 molarity solution. That's how concentrated it is. So I could tell you, I said, well, Mrs. V, I have a 1, we call it molar, 1 molar solution and a 2 molar solution. I can tell you of maybe salt water. I can tell you the 2 molar right off the bat, I know, is a higher concentration of a salt water. It has more salt in it because it has a higher molarity. Okay, so I did make for you the triangle. If you guys remember, use those for a lot of our equations. So molarity is for measuring concentrations of solutions, how concentrated they are. And I guess one example I could use too, which I wish I could have done, and maybe I'll do it with my kids. Usually what I would have you guys do is make different concentrations of Kool-Aid. So it would have different concentrations of sugar in it. And you would get to taste them. And you would figure out which was the right one, or which has the right molarity of sugar for Kool-Aid. Okay? So you can even try that at home. Maybe I'll post that. Maybe I'll get my kids to do it with me and I'll have them try it, because some of them that I had you guys make, whew, they taste really bad. And that's a higher concentration or higher molarity. But molarity is the moles of solute per 1 liter of solution. Okay, liter is a big thing. Okay, the symbol is M. Example, a 1 molar sodium chloride solution tells me that there's 1 mole of sodium chloride in 1 liter. Okay, and so here's our little triangle here. Molarity equals moles per liter. So you put moles on the top, okay? And then you have molarity here and volume here. So if you cover this up, we'll cover this up. And molarity equals moles. Molarity equals moles divided by volume. If you want to know the moles, it's molarity times volume. If you want to know the volume, it's moles divided by molarity. So you guys can use this triangle as you guys are going through not only the Poggle and the worksheet, but you can also go use it when you guys are using your quiz. Okay? All right, so let's do a couple examples. So given grams or moles dissolved in liter or milliliter, find the molarity. So our question is 3.62 moles of potassium hydroxide dissolved in water to make 4.82 liters of solution. So just like we've always done, always label your things. So this tells me my moles, 3.62 moles. It goes in the top of my triangle. The next known is this 4.82 liters. So that goes in this part of my triangle. Now I'm trying to find molarity. So this is my question. So again, I'm going to take 3.62 divided by 4.82 to get my molarity. Okay? And if I do that, I get 0.751 is my molarity. Okay? All right, let's look at another one. So, given grams or moles and liters or milliliters, find molarity. So, we're going to start here with 6.92 grams. Notice, this is not in moles. Now, you guys all learned how to calculate molar mass and how to take grams to moles. You will need to do that. And if you noticed, if you start with grams, you will need to divide by your molar mass. If you start with moles, you will need to multiply by your molar mass, okay? So that's one thing you can start to remember. If you start with grams, you divide by your molar mass. If you start with moles, you multiply by the molar mass, okay? So you would have to figure out the molar mass of magnesium carbonate and are dissolved in water to make a 0.750 liters. So we don't have to worry about changing those of solution. Okay, find the molarity. So the first thing you're going to do is you're going to turn this grams into moles. And like I said, since I started with grams, I'm going to divide by the molar mass. And the molar mass of magnesium carbonate is 84.3. So 6.92 divided by 84.3 gives you 0.0821 moles. You are also given the liters, which is 0.75 liters. And again, to find the molarity, okay, it's 0.0821 divided by 0.750 gets you 0.109 molarity. Okay, all right, let's look at another one. How about if you're given a molarity and either grams, moles, volume, in milliliters or liters, okay? So let's read. How many milliliters, so it's asking it for milliliters. Remember when we calculate through molarity, you're going to get liters. So then you have to convert to milliliters. Of a 2.17 molar, so this is our molarity, sodium nitrate solution contains 2.63 grams of sodium nitrate. Notice again, we're starting with grams. So we need to convert it to moles, okay? So we're going to need to get that molar mass, divide by it again. So molar mass of sodium nitrate, divide 2.63, and it's 85 to get 0.0309 moles. The next thing I have in here is my molarity, which I can go ahead and plug in, which is 2.17. Now I have these, so now I'm going to look for my volume. And again, it tells us to divide 0.0309 divided by 2.17 gets you, at first, you'll get 0.0142 liters. But remember, we asked it in milliliters. So we have to convert it by multiplying by milliliters. So 0.0142 times 1,000 gets you my volume of 14.2 milliliters. For those of you that don't want to do this and just want to move it, those three places, 1, 2, 3, either way will work. Okay? All right, let's look at another one. So, given molarity or milliliters or liters, find moles or grams. So, how many grams of sodium chromate are in 206 milliliters? Notice this is not in liters. Of 0.217 molarity solution. Remember to convert your units first. So, we already know we have a 0.217 molarity. We don't have to convert that. But we are going to have to convert our milliliters into liters. You cannot plug in milliliters. So 206 milliliters divided by 1,000 gets you 0.206 liters. Or for those of you who just like to move, 1, 2, 3. Okay. And we want to know our moles. Well, this is the one that's empty. So what will we do? We multiply them together. 0.217 times 0.206, and you get 0.0447 moles. Okay? That gets us moles, but if we go back to our question, it says how many grams. So now what we need to do is take our moles and convert them back over to grams. Now remember, I said if you start with moles, you need to multiply by your molar mass. So 0.0447 times 134 will get you an answer of 5.99 grams. All right, so I hope that helps a little bit, but I'm also going to do a few examples here on this video of the two things you're going to do after this. The first one is your Poggle, kind of explaining a little bit more about molarity, and then I'll do an example off of your worksheet molarity calculations as well. Okay, but first here, give me a minute. I'm going to actually bring up the calculator here on my computer so that I can be ready to go. There we go. Okay, so let's look at the Poggle. So when you buy a bottle of certain brand of lemonade, so they're talking about lemonade, of course, the lab I will do or send out will be Kool-Aid. You expect it to taste just as sweet as the last time you bought that kind of lemonade. Likewise, when doctors prescribe a certain ointment, they expect the concentration of medicine to be consistent. How do companies ensure their products taste or perform the same every time you purchase them? Many companies, including pharmaceutical companies, keep track of the concentration of a solution by measuring its molarity, a ratio of number of solute particles to the volume of solution. In this activity, you will learn about molarity and how to represent concentration quantitatively. So, lemonade mixtures. You have lemonade solution number 1. You have lemonade solution number 2. Notice there's dots. That represents our solute, okay? And if you can't remember the definition of solute, go back to solutions and get those definitions. Okay, so more dots means more solute, okay? So let's look. So we're going to look, I'm going to look here, okay, at number 1, but I'm going to go ahead and skip A and B because those are definitions from solutions. So if you guys need those, go ahead and go back. What is a dissolved lemonade mix particle represented by? Well, we just talked about they are represented by the dots, okay? Number 2, circle the word that best completes each sentence below and justify your answer based on the diagrams in Model 1. Lemonade solution 1 has more, less, or the same volume of solution as 2, okay? So they're talking about the volume, not the molarity, not the moles. We're talking about the volume. And if you look at it, they're pretty much the same. Okay? So, okay, it is the same. And how do you know? By looking the level in the picture looks the same. Okay, so remember the one thing I always told you guys, when you guys are doing these Poggles, do not overthink them. Answer the question they're asking. Okay, they're not trying to trick you, they're not trying to make it hard. They are simply just asking these questions. So I'm going to go ahead and leave you guys to go ahead and answer, and they're going to ask more about that lemonade solution all the way through 5. Okay? All right, so let's do a little example here on this page. So I'll just do number 1 as your examples, and then I want you to go ahead and do the others on your own. So you have number 1 here, and it tells us it's a 1 molar Cooper chloride solution, 0.16 moles of copper chloride in 0.06 liter solution. Remember, and you may want to write this on your paper, we have our triangle, we have molarity, we have moles, and we have volume. Okay? And remember, this is liters. Okay? So, we have here 1 molar copper chloride solution. And you know that because look, 0.06 moles divided by 0.06 liters equals 1. Okay? So they're going to ask you a few questions about these. And it says here, let's look at number 6. Okay. List the beaker numbers for solution mol 2 that are considered to be concentrated. Remember, concentrated means there's more stuff in it. There's more moles in it. If you're making Kool-Aid, there's more sugar in it. Okay, it's sweeter, just like lemonade. Okay, if you add more sugar. So you're going to look at the more concentrated ones. And remember, our dots talk about our solute right here. So you can either think about salt water or sugar water. And these ones right here, concentrated, 3, 4, and 5. And they even label it for you right there. Remember how I talked about? Okay. Answer the question they give you. Okay. So I'm going to have you guys go ahead and look at those on your own. Okay. And then it starts asking about calculate the ratio of the moles of solute to liter solution for each solution. I just showed you that one on the other side. Okay. And then how does the ratio compare to the molarity? And all they're talking about is this is a ratio. Okay, that is the ratio. You can write it this way, or you can write it, you might see it in math, this way, or 1 to 1. Okay, all of those are the same. Okay, so then go ahead and answer those questions through there. Okay, and then you're going to talk about 14, they're going to start saying calculate the molarity. Okay, remember your triangle. Okay, write it maybe on every page. Moles on top, molarity, and liters. Okay, so it'll have you do a bunch of calculations there. Okay, and yes, you're going to go ahead and you're going to do the extension questions as well. Make yourself think a little bit. Okay, all right. The next worksheet you'll work on the next day. Okay, you can finish that one day and then you can work on this the next day. Is your molarity calculations. I've already put my triangle here for moles, molarity, liters. Okay, so let's look at number 1. 2.3 moles of sodium chloride in 0.545 liters of water. We have our moles and we have our liters. Okay. So molarity will equal, if we cover that, it's moles divided by liters. So we'll do 2.3 moles divided by 0.45 liters. You don't have to convert, so it's in liters. So let's go ahead and 2.3 divided by 0.45. You will get, and you can round everything to the nearest tenth, 5.1 molarity. And that's what you're going to do for this entire worksheet, okay? Please take note, some of them are in milliliters. So please, you can also write on the top, 1 liter equals 1,000 milliliters, okay? Or you could write it 1,000 milliliters in 1 liter. Or you could write it 1 liter for 1,000. Remember, our conversion ratios can be flipped back and forth. You can write it either way. So I would recommend before you do this, write your triangle, write your conversions on the top, and then go through it. Sometimes you're also, let's see, what else do we have? This says liters. It should say liters, by the way. There shouldn't be an extra T. We're not talking about kitty litter. Talking about liters. Okay. Notice this was in grams. So here, again, you go back to the notes that I just did for you. You will need the molar mass, okay, of NaOH. Okay. And then down here, I'll give you a couple other ones where they give you molarity. 2 liters of a 6 molar hydrochloric acid. Okay. And you want to know how many grams, not moles, how many grams. So you're going to need the molar mass. You're going to need that molar mass each time here too. What the heck do we use this for? I use this in every lab every time I've done it for you guys. I read instructions. It tells me the molarity to make a solution. And I go ahead and make it. Sometimes I make it from a solid. And I have to weigh out the grams and add that to water. 1 liter of water. And then sometimes I get a certain molarity, and we're not going to go through it, but I dilute it if I need a weaker molarity solution. So all of this matters, okay? It all matters. This right here, if you remember when I did the making of the water, and I used that hydrochloric acid, that hydrochloric acid was a 12 molar solution. It was extremely strong and extremely dangerous. So the higher the molarity, the more dangerous some chemicals are. Okay, so that's really important to understand when you're working with chemicals. But it is also important when you're looking at, you can calculate molarity of things around your house. So I will find that Kool-Aid lab. I'll post it up for you guys to have a little fun with if you'd like to. Since this week, remember, this is it. Once you guys finish this molarity worksheet, you guys are done for this week, okay? And the stuff that is still in your packet, if you have a paper packet, will be moved to next week. And it'll still be in the next packet, so if you want to turn in that whole second packet, okay? All right, guys, well, I hope you're doing well. I miss you, and hope to see you soon. Bye.